Hello, guys. So now we will talk about inferential statistics. And this particular topic will also help us to understand what is central limit theorem. Now, central limit theorem is a very important concept when it comes to statistics and when it comes to data science, even for data analytics. So let's get started and understand what is central limit theorem. And before that, what is inferential statistics. So when we talk about inferential statistics, now the very first thing is let's understand the problem statement. So let's say this is the entire population. Let's say the entire population of urban India. Now, what we want to do is, let's say you work for a small marketing company. So you work for a small marketing company and your manager wants you to find out. So your manager wants you to find out on an average how many people in urban India visited mall last year. Let's say this is the question that your manager is willing to ask you and your manager wants you to find out how you will do it. Just pause here the video and try to understand or maybe try to think how this can be done. Now you guys would have already thought about something, but let's try to understand how this is actually done. So you as an individual cannot ask each and every individual. I hope you will agree with this. So here in this urban India population, how many people are there in urban India? So I exactly don't know the count, but let's assume 50 CR, which is 50 crore. So if there are 50 crore people who are living in urban India, and if you want to basically find out the answer to this question, what exactly you need to do? You need to reach out to each and every individual and ask whether they have visited the mall last year or not, and basically how many times they have visited. So let's say you will ask each and every individual and you will collect the data. So let's say person number 1 visited for 2 times, person number 2 visited for 7 times, person number 3 visited for 10 times, and so on till person number 50 CR visited for 2 times. Now, first of all, what I have written in front of you, is it possible? Is this data collection even possible? The answer is a no, because just think about it. You as an individual cannot perform such a large scale survey. Now, this is known as a survey process. This is known as your survey process. And you as an individual cannot perform such a large scale survey. Now, there are two problems. Number one, the reason a small marketing company cannot perform such a large survey is because they don't have such a huge workforce. So, not having a huge workforce. Number second is they don't have even that much amount to invest on this process. So, no budget, right? So basically, if you think about census that happens in India, now census in India takes approximately 6 to 7 months of the time, and Indian government spends around 10 to 20 crores rupees. The entire amount is more than my estimation, but the amount and the time that Indian census or Indian census process takes is because Indian government want to reach to each and every individual of this country and collect their individual data, so that Indian government can understand how the entire country looks like, what is the distribution of income, what is the distribution of gender, what is the distribution of other parameters. But if you think about a small marketing company, their objective is to not collect accurate data. While if you think about Indian government, their objective is to collect accurate data. Now, if you think about this small marketing company, their objective is to get approximate data or approximate result, because they want to make certain assumptions that are backed by some data. Now, let's say they are planning some kind of marketing activity for which they want this answer: how many people on an average visited the mall last year? So for some marketing activity, they want this answer. Now, it is not necessary that we need to get them the exact number with exact decimal point, but that's not required, right? So, for example, even if I can help this marketing company with the approximated range, that will also satisfy their objective. So, when we talk about the objective of inferential statistics, it's basically to get us the approximated result from this population. But how this can be done? Now, what this marketing company and what you as an individual will do is you will take a small sample. So this is my sample. Let's say this sample has some 1,000 people, and you have randomly chosen some 1,000 people from your 50 crore population. And now you as an individual can pretty much easily perform survey on this or on those 1,000 people, right? Now, once you have the survey result, let's say person number 1 visited for 5 times, person number 2 visited for 2 times, person number 3 visited for 7 times, and so on till person number 1,000 who visited for 10 times. Now, this data and this process is pretty much doable. Why? Because reaching out to 1,000 people and asking them whether they have visited the mall last year or not and how many times they have visited is pretty much easy, right? You can do it. Now, once you have this result, I want to find out average. So let's say my average came out to be 3.5. Now, inferential statistic will help you to use this value. So I will use this sample statistic or sample result to approximate the population parameter. So using sample statistic to approximate population parameter. Now, please remember one thing. If you have a sample, so let's say this is my population and this is my sample. So when you find out the mean, median, mode, standard deviation, and variance for the population, these are known as your population parameters. And when you do the same thing for the sample, this is known as your sample statistic. Basically, the process of inferential statistic is to use the sample result. So what I have done, I have here taken a small sample out of the entire population of 50 crore people, which is of 1,000 people. And then I have surveyed on these 1,000 people to get my data, to get my result. On top of this data, I have found out the metric, the statistic. And now the process of inferential statistics will help me to use this sample statistic to approximate the population statistic. So when I say approximate, I'm basically willing to find out a range. So what that mean? So in my sample, the average number of time a person visited the mall is 3.5. Now, can I somehow approximate for the population? So in the population, can I somehow find out the range, which is the minimum and the maximum? Right? Sounds interesting. So we will talk about it, like how to find it out. Let's continue the discussion. Now let's try to understand what exactly is central limit theorem and how central limit theorem can help us to solve this problem. CLT. Let's recap the process. We have this entire population of 50 crore people. Now what we will do is, I will take a small sample, let's say of 1,000 people. And now we will survey on it. So we will collect the data. Person 1, let's say 5 times. Person 2, 3 times. Person 3, 2 times, and so on till let's say 10 times. Now I will take the average of this. So let's call it as mu S1. So this is my sample number 1. Let's say it came out to be 2.5. So in this particular sample of 1,000 people, the average number of time a person has visited the mall is 2.5 times a particular year. Okay? Now, if I take another sample of new 1,000 people, again random, H2, 1,000. Again, we will have P1, let's say 2 time, P2, 9 time, P3, 7 time, and so on till P1000 for let's say 8 time. Let's say the average of this is mu S2 is 3.8. If I take another sample, S3 of 1,000 people, and I do the same thing, collect the data after survey, P1, 2 time, P2, 3 time, P4, 5 time, and so on till P10 or 1000. So here also 1000, let's say 10 times. Mu S3, let's say came out to be 2.8. Now, central limit theorem states that number one, the average of all the sample mean is approximately equals to the population mean. Now, basically, the average, if I take the average of mu S1, mu S2, mu S3, and so on, it will give me mu P approximately. That's the first finding of central limit theorem. Second is the standard deviation of the sampling distribution is given by sigma divided by root of n. Now, what is sampling distribution first of all? If I take all these sample mean, which is mu S1, mu S2, mu S3, and so on, let's say I have taken mu S100. So I have taken 100 samples for which, so these are my sample 1, sample 2, sample 3, such as all these are my samples. I have taken 100 such samples. Now for all these samples, I have performed the survey. And then after performing the survey, I have calculated the sample mean. So I have mu S1, mu S2, mu S3, and so on. Now, if I plot this, all these sample mean, I will get a distribution which appears to be normal. So this is known as my sampling distribution. So here you have mu S, all the sample means. Now the standard deviation of this sampling distribution, so here you will have mu P, the average of all the sample mean is approximately equal to the population mean, and the standard deviation is basically given as sigma divided by root of n. These are basically the two findings of central limit theorem. Let me show you and prove this in one of our sample data, and let's first of all understand whether this is valid or not. Once we prove it, then we will also look at how this can help us to find out the range. Let's try to first of all check the proof. So here I have a data. Here we have, let's yes, data.txt. Let me copy the path. So let's import pandas as pd. df is equal to pd dot read underscore csv and df dot head. Now here, this is the data of, let's say, so let's create a hypothetical business problem. So let's write down the business problem. Now the business problem is, let's say, Tata shops are planning to launch their new shops across India. They already have, let's say, 100 shops across India with more than lakhs transactions happening per shop per day. Now you guys can see the amount of data that they generate. How much data do we have in this particular file, df.shape? So here we have 1, 10, 100, 1000, 10,000 lakh, around 5 lakh data points. So now, basically what Tata want to do, they want to use the data, which is right now the sample data, and understand the range of purchase for males and females males and females in entire India. So right now, this particular data is of, let's say, some random 5 lakh transactions that were done by the customers. So each row is a transaction. So these are random 5 lakh transactions. But in reality, Tata is doing 1 lakh transactions per shop, and they have 100 such shops. So you can think this is around 10 million transactions per day. Now, using the sample data, Tata wants to understand what is the range of purchase for males and females. So how much males are spending, what is the range? How much females are spending, what is the range? Now, again, here, since we are working on a sample data and we are not working on a entire data of 10 million transactions, we can only find out the range and not the actual average amount. Okay, so the reason I have written they want to use the data and understand the range of purchase and not the average purchase is because using CLT, we can find out the range, not the exact value. And that was the motivation of learning CLT. We will find out this range after I teach you how to find out the range. But right now, let's see if the CLT algorithm, the two clauses that we talked about, is valid or not. So what it states, CLT states that number one, the average of all sample averages is approximately equals to the population average. Second is the standard deviation of the sampling distribution is given by sigma divided by square root of n, where sigma is population standard deviation and n is the number of observations or data points per sample. Okay, let's do this task. So what I'll do, I'll only take the purchase column from the data frame df. So df purchase. So this is my series, and from the series I will randomly pick, let's say 1000 observations. So dot choose. I hope choose command is correct. 1000. Okay, choose is not correct. So what is the correct one? Dot random. 1 second. Let me just cross check what was the command. Just give me a second, guys. You guys can a little bit fast forward this video. Okay, the choice I think was the right one, but I can use np.random.choice, np.random.choice, and df purchase. I need to import numpy also. Let's do this. Import numpy as np. Okay, 1 second. We need to also mention 1000. So here we have 1000 random values from this particular series, which had 5 lakh rows, right? Now this is one random sample. I want to take the mean of the sample. So let's take the mean. The mean is 9270. Now this is mu s1. So what I'll do, I'll quickly write a loop so that I can take 100 such sample means or 1000 for I in range 1000. I want to do this process for 1000 times. And every time what I'll do, I'll just preserve it in a list as sample mean. So let me also preserve this in a variable a, and then I'll simply say sample mean dot append a. Now let's plot a as a histogram. So I'll ask my Gemini. So plot sample mean as a histogram with the PDF. Let's see. So let's run it. Now here you can see we have the histogram. So the black one that you see is the basically your standard histogram or a standard normal distribution, and the one you see on blue is approximate. You can see that that the particular curve you're getting is very similar to normal, right? Now this is known as a sampling distribution. Okay. Now for this distribution, the mean. So if I say take the mean of all sample mean, so sample mean, I will convert it into an array, and then I'll simply take the mean, sample mean dot mean. So the mean, this value is the mean of all sample mean, and it will be equal to the or approximately equal to the population mean. Assuming that this is the entire population, let's take the mean df purchase dot mean. Now you can see that this value 9272 and 9263 are very close to each other. So this is the first proof of central limit theorem. Second proof is the standard deviation of this particular distribution. So the standard deviation is given as, first of all, I will find out the standard deviation of the entire population, which is this. And if I divide it with np dot square root of 100,000, because we were having 1000 observation per sample, the value is 158. Now this is the standard deviation of this particular sampling distribution. Now, if I have to find out the range, I hope everyone is clear till this point, and I assume that everyone is clear. Now, if I have to find out the range once we have these two sample mean and the standard deviation. So if I have to find out this range, let's say, where we get, let's say, the 90% observation or 68% observation, what I'll do is, in this sample mean, which we have calculated, I will add and subtract the z times of sigma divided by root n. Now, as you guys can recall from the last discussion that we have, z is the number of standard deviations from the mean or the average. So how much below and how much above you want to go, or like what is the range you want to approximate? That's what you have to enter over here. Sigma is your population standard deviation, and is basically number of observations per sample, and this is your sample mean. Now, this z value, we can calculate it uh, based on uh, basically how many observations. Basically, you guys have also learned that 68% observation lie between plus minus 1 standard deviation, 95% between plus minus 2 standard deviation, and 99.7% between plus minus 3 standard deviation. So I can go with this also. I can go with these numbers also, 1, 2, 3, and then accordingly you will get the particular range of the limit. So if I go back, let's say I want to find out, I want that 68% limit I want to find out. So I'll say this value, which is my sample mean. So I'll save it as mu s, and I will save it as mu, oh no, not mu p, it is ss, let's say sample standard deviation. So here my range will be mu s minus ss, because I want to go 1 standard deviation below, and mu s plus ss, 1 standard deviation above. 1 second. Okay, s underscore s. Now, what this mean? This basically mean that number one, 68% of the sample means will have the average purchase between 9114 to 9431. That's one of the finding that we can conclude, that 68% of the observation, or 68% of the samples will have the mean between this range. Second interpretation is that 68% chances are there that the population mean will lie between this range. So there are 68% chances that your actual sample mean, actual population mean will lie in this range. Okay. Now, I believe some of you might have got clarity with this concept of CLT. There would be a lot of people who are not clear with this. So what we'll do is we're going to take few examples to help you understand this, and then we will also solve this problem about male and female, and then it would probably help you. So let's take a quick pause over here and continue with the next video. So let's try to solve these questions and try to understand how CLT can be useful. And the first question, it states the mean recovery time of 100 patients was seen to be 10.5 days with a standard deviation of 2 days. Find 95% confidence interval of true population mean. Now, with this information, what I will do, I will first of all plot the sampling distribution. So my sampling distribution will have a mean of 10.5, because right now I only have one sample. So I'll assume that this is the mean of all the sample means. So my sample mean mu s is 10.5 with sigma. Now, this is not population standard deviation. This is sample standard deviation. Again, since we don't have the data, I'll say this is my population standard deviation of 2 days. Now, for the sampling distribution, this is my sampling distribution. My standard deviation, which is also known as standard error, SE, is given as sigma divided by root of n. Now, sigma is 10.5 divided by, now here we have 100 patients, so root of 100. Now, this standard error, if we calculate, would come out to be, let's check. So I think I haven't calculated it. Let's keep it as it is. One mistake I have done over here, the standard deviation is not 10.5, it is 2. So let's keep it as it is right now, 2 divided by root of 100. Now, I need to find out the range. So my range would be mu s plus minus z times of sigma divided by root of n, right? Now here, my z value will be 1 point plus minus 1.96. So I hope you guys remember that 95% of the data will lie in plus minus 2 standard deviation. Here we have to find for 95%. So basically, here 95% of the data should be in the middle range, right? Now, since the number that I told you, which is 68% of the observation will lie between plus minus 1 standard deviation, 95% is going to lie between plus minus 2 standard deviation, and 99.7% between plus minus 3 standard deviation. All these information are basically done on a very detailed data after a great amount of research, but actually the value is this. So 95% of the data would be between plus minus 1.96. Plus minus 1.96 is the actual number. So how I will solve this? I'll say 10.5 minus 1.96 times of 2 divided by root of 100, comma 10.5 plus 1.96 times of 2 divided by root of 100. Okay, let's find out the actual answer. I'll use again Python for that. So let's use this. Here, my mean M is 10.5. My standard error is 2 divided by NP dot square root of 100, not 1000. And then M minus 1.96 times of SE and then plus. So 10.108, 10.892. So here we will have 10.108, comma 10.892. Okay. Now, this basically means that, let me write it over here. The mean recovery time of all patients in the population will be between 10.108 days to 10.892 days, and we are 95% confident about this. Or I can say that there are 95% chances that in the population, the patients will take 10.108 days to 10.892 days to recover if they take this particular drug. Now, this is how we have used CLT to solve this problem. I will take a pause and I will ask all of you to solve the next question just to get a better understanding. You guys can pause this video and then you can resume it to see the solution. Okay. Now let's try to solve this problem, the second one. A group of 100, so N is given as 100, found watching cartoon for 3.5 hours per day on an average. So my sample mean is 3.5 hours and a standard deviation of 1 hour. Again, we don't have population standard deviation, so I'll assume that this is population standard deviation. Find 95% confidence interval. So I'll again initiate the sampling distribution. Here, this is going to be 3.5 and I want to find out this value and this value, which corresponds to 95% confidence interval. So this area is 95%. Now we know how we can do it. So again, mu s plus minus z times of sigma divided by root of n. My z is plus minus 1.96 right now, which corresponds to 95% of confidence interval, right? Now, mean is 3.5 plus minus z is 1.96 times of 1 divided by root of 100. Let's try to find this out. 3.5. I'll copy this. I'll just change this to 3.5 and this will become 1 divided by root of 100. Let's run it. So 3.304, 3.696. So here the answer is 3.304, 3.696. Now, what is the meaning of this? This basically means there are 95% chances that school students, now when I say school students, I'm talking about the entire population. School students would be spending 3.304 hours to 3.696 hours on an average a day watching cartoon. Okay. So basically, I hope you guys would have understood the advantage of using and learning central limit theorem. It basically helps you to approximate for the population using the sample statistic, using the data which you obtain from the sample, because it is not possible for us to perform survey on the entire population data, right? That is the reason we use central limit theorem. Now, before I jump forward to teach you the next topic, let's quickly also complete this question. So the company Tata Shops wants to understand whether the purchase range for males and female is the same or different. We have already obtained the sample mean and so this was my sample mean mu s. I think it is, let me add a row over here. So it was mu s. This is my sample mean and sample standard deviation was s underscore s. Now I will do this thing for males and females separately. So what I'll do is I'll copy this, put it over here. And instead of just finding it for purchase, we will filter it for gender. So I'll say DF. I hope G is capital, yes. So this will result is equal to male. I hope M is capital, yes. Now this will result in the data for only males. Why I'm getting error? DF of gender is equal to male. Let me run this. Okay, where is the error and why is the error? Okay, here should be double is equal to. Okay, and from this I will take purchase. So let me just put double is equal to. So this will be for male. So I'll put a male over here, and I'll put a male over here, and everything remain the same. So let me delete this first of all. Run this. Let me do it for female also. So let me run this also. Now, once we have this, I would also need to convert it into array to calculate. So here it will be male, here it will be female, here it will be male, here it will be female, and here also male, here also female. I can write M over here, I can write F over here. Okay. Let's wait for this code to run. I'll take a pause over here. Just let me complete, let it execute, and then we'll proceed. So this is done. Let's calculate the mean. Oh, sorry guys, I executed it again. So let me run this. Once we have the mean, the standard deviation is going to be different for both of them. So let's calculate for male. For male, I will just copy this piece of code, put it over here, and this will be for female. So let's put F over here. Similarly, I will have M, male. So let's copy, put it over here, male and male over here. And let's execute this one also. So we have mean and standard deviation, which is standard error for both male and female. Now I need the range for male. I hope you guys remember that for 95% it is 1.96 plus minus 1.96. So I'll do the same. So I'll just say 1.96. Here I'll multiply. Here 1.96. Here I will multiply. So this is for female. Sorry, male. I'll add one more, and this will be for male. Sorry, female. F F F F. Let's run this. Let's run this. Now here you can see that the range for male is from 9118 to 9749. So let me just write it down. So for male, and I'll show you, just let me write it down first. For male, it is 9118 to 9749. For female, it is 8446 to 9037. Now, one thing that you can, so this is for male and this one is for female. One thing you guys need to notice is there is no overlap between these two ranges. This is the range for female and this is the range for male. So that basically means, number one, there is a difference in the purchase amount for males and females, right? There is a difference. If there would have been an overlap, I would have said that in the population, the purchase amount for males and females is approximately the same. But right now, you can see that the range is also different. That means in the population, the purchase amount for males and females is substantially different, right? So 95% chances that in the population, the male will spend between 9118 to 9749, while female between 8446 to 9037, right? So this basically mean Tata shops. So they want to use the data to understand the range of purchase for male and female. What is the answer for this question? The answer is, number one, there is a difference in the purchase range for males and females. Second is for male, the range is between 9118 to 9749 with 95% confidence. And for female, it is between 8446 to 9037 with 95% confidence. Right? Now, this is the solution to this particular problem. Okay. Now, I hope till this point you guys would have gathered and gained good amount of confidence when it comes to inferential statistics and how CLT can help us to solve a problem. One thing that is pending from my side is to understand or to make you guys understand the process of sampling. Basically, as I have told you that I have picked here in this particular sample, I have picked 100 random people. But how? Is there any rule that we follow? So we have to spend our time understanding some of the sampling techniques. So this process is known as sampling. And we need to understand what are the sampling techniques. So I will quickly take a pause and I'll start the various sampling techniques. Now let's talk about some of the sampling techniques. Basically, from this particular population, how we can take out a sample. Now, there are various kinds of technique. Some are probabilistic, some are non-probabilistic. So we have sampling techniques divided into two buckets: probabilistic, non-probabilistic. In probabilistic, we have random sampling. We have stratified sampling. Cluster sampling. And we have systematic sampling. In non-probabilistic, we have convenience. We have quota, judgment, and snowball. These are the sampling techniques. To help you with a very simple distinction between what is probabilistic and what is non-probabilistic, here we use some kind of mathematical logic to perform the selection. So mathematical logic to perform the selection. Whereas in this case, it is all about the person and the person opinion. So if I am performing the sampling, I will be the person who will decide which all observation will be in my sample. So it is up to me. So it is on personal opinion. Personal opinion. Let's talk about, first of all, random sampling, which is also known as simple random sampling. So in the case of simple random sampling, what we do is, let's say this is my population with 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We have 10 numbers or 10 observations. And I need to select 3 data points or 3 observations. Now the point is that in simple random sampling, it is basically to select any 3 observations without your personal opinion. Any 3 observations without your personal opinion, such that the probability of each observation to select from the population remain the same. So what is the probability that I'll select 1? It is 1 divided by 10. What is the probability that I'll select 2? It is 1 divided by 10. What is the probability that I'll select 3? It is 1 divided by 10. Probability that I'll select 4, it is 1 divided by 10. And it is same for probability 10 also, 1 divided by 10. So that basically means the probability to select any observation from the population remains the same. Now, why it is same? Because I have not applied my personal opinion on it. I am saying that if I have to select either of these or maybe any one from these 10 observations, I will simply pick any random 3 observations because I need 3, any random 3 observations without my personal opinion. So select any random 3 without your personal opinion added to the selection. Added to the selection. So basically, I can select any random. So I selected 3, 5, and 9. And these are just random without any thought process. So this is your simple random sampling. In simple random sampling, the probability to select any observation from the population to the sample remains the same, right? Second one is stratified sampling. Now in stratified sampling, what we do, we also try to maintain the proportion or the group in the sample. For example, let's say this is my population. In this population, we have 20% people who use, let's say, iPhone, 50% use, let's say, Android, and 30% use none. Now I want to, and there are, let's say, 100 people in this population. I want to select 10 people in the sample. So this is my sample, and I want to select 10. Now, in stratified sampling, so the term strata, S-T-R-A-T-A, strata, means group. So in stratified sampling, I will make sure that the sample also maintains the proportion of the groups. So while selecting the observations for the sample from the population, we will make sure that the proportion of groups in the population is maintained in the sample. So how I will do this? I will take 20% of 10. This is 2. 50% of 10, 5. 30% of 10, 3. So now I will take 2 random people from iPhone group in the population, then 5 random people from Android group, and 3 random people from none. So this is how I will select. This is your stratified sampling. Now the third one is cluster sampling. So in cluster sampling, what we do, let's say this is my population, and it has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, and 20. Now let's say I want to select 5 observations. Sample of 5. Now what I will do, in my population, I will group all the observations in a bucket of 5. So in any random order, let's say 1, 2, 3, 4, and 5. So this is one group, 1, 2, 3, 4, 5. Another group, 1, 2, 3, 4. So let's create another group, which is this. Another group, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Another group over here. So this is my step number 1. Randomly group the observations in the population same as of sample size. So my sample size over here is 5. Then randomly pick any one group. So let's say I chose to pick this one. So this one was 3, 4, 5, 9, and 10. So this is my sample. This is known as cluster sampling. The last one is systematic. Now here what we do, we follow a systematic approach. So let's say this is my population. Again, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, and 20. Now, let's say I want to select 4 observations in my sample. So this is my sample with 4 observations. So what I'll do, first of all, I will divide. So 20 divided by 4 is 5, right? I will take every fifth observation. Now this 5 is taken based on some calculation, 20 divided by 4, but in reality it might not be possible. So you can systematically choose your window. You can decide that I will take every second value or every third value just to be unbiased. So every fifth, I'll start from here, 1, then 2, 3, 4, 5. So I'll take this. So 1, 8. Then from here, I'll take 1, 2, 3, 4, 5. So let's say 19. And then from here, 1, 2, 3, 4, 5, 12. So these are my 4 values. So choose a window, which is, let's say, X, and then take every Xth observation from the population to the sample. This is your systematic sampling. Okay. Now let's talk about what is non-probabilistic sampling. So let me take a quick pause. Now in the case of non-probabilistic, the first one is convenience. Convenience. So let's say there is a class and this class has 100 students. Now, principal or management, so this is management, is asking the teacher of the class teacher, to select, let's say, 10 students. Now, this class teacher will do the random selection. That's correct. But the class teacher will also add his or her opinion in the selection. So, since the class teacher will select 10 students based on his opinion, this becomes convenience sampling. Now, let's say this task was not done based on his opinion, his or her opinion, then it would have become the random sampling. So when you add your opinion, your point of view, you are basically talking about convenience sampling, basically non-probabilistic. You are being biased. So if the principal is asking me to select 10 students, I would probably choose the one who are good students. Probably I will give more weightage to girls, right? That becomes convenience sampling. Now we have quota sampling. Again, we have a class, 100 students. Principal is asking, or the management is asking to select. So this is my class teacher. Now, the management is asking, select 10 students, but there should be 3 girls. Now, what this teacher will do? This class teacher will first choose 3 girls. So basically in quota sampling, we are giving a quota to a group. Now here the group is 3 girls. So I'm giving a spatial quota to a particular group. And then I will choose the rest of the observations in the sample based on convenience. So the teacher will first choose 3 girls because of a spatial quota, and then will continue with convenience sampling to choose the rest. Okay. Third one, so convenience quota. And then we have, one second, judgment. Now judgment and snowball. In judgment, the selection is not based on one person. You can think of Indian Idol. So here we have, let's say, thousands of participants in Indian Idol audition. There's thousands of participants for audition. Now this selection, so from this audition, let's say I have to select top 10. This selection is based on 3 people, right? We have 3 judges. So here the selection is not dependent on just one person. A group of people are doing a judgment to make the selection. So the selection of the observation from the sample is based on the group of people and not on just one person, right? And the last one is your snowball sampling. Snowball. In snowball, the next selection is made by the previous selection. Let's say we have students sitting in a row. So row number 1, row number 2, row number 3, row number 5, row number 7, row number 4, row number 6, row number 8, row number 9, and row number 10, 12, and 11. Now we have to select, let's say, 3 students. What I have done, I have chosen, so I chose 2 as the first observation. So 2 has been selected. Now I will give flexibility, or I will ask this observation to choose the next. Now this selected observation will choose the next. So now the next one is your, let's say 2 decided to choose 9. Now 9 will decide to choose next, let's say 12. So we have 2, 9, and 12. This is your snowball sampling. So this is basically various ways of performing sampling. Again, not a very important topic. One of the sampling technique that I always ask my student to focus most is the stratified and the simple random sampling. These are the 2 sampling techniques which you will frequently find out in your data science and the data analytics journey. Apart from that, it is good to have the knowledge of all. So this was for knowledge purpose, but the main objective of this module was to help you get familiarized with the concept of inferential statistics, and more important, how to use inferential statistics to solve a business problem. I hope you enjoyed this particular module. I will see you in the next.